Welcome to Math Minders Academy. Today in our tutorial class, we are going to look at solution to June 2024 IGCSE Mathematics Paper 4.1. If you are new to our channel, go ahead and click on the notification bell so that when next we release a new video, you'll be among the first to get it. Subscribe so that you become one of our community members. So let's move on to the paper. Looking at this paper, this is meant to last for 2 hours, 30 minutes. So we are going to break the tutorial video into 2 volumes or 2 parts. So this is part 1. And if you watch part 1, you also want to finish it up by watching part 2. We are going to give you a link to this particular paper so that you can have access to it, download it, practice it on your own, then watch the tutorial video and use it to assess yourself. Question number 1. Number 1A says the table shows the areas in square kilometers of the 4 largest rainforests in the world. So we have Amazon, Congo, Atlantic, and Valdivian. And their areas are given here. Their areas are given in square kilometers. So here we are asked to find the area of Valdivian rainforest as a percentage of the area of the Amazon rainforest. So here we'll have, for the Valdivian rainforest, we have 250,000 over the Amazon rainforest, which is 5,500,000. So here I will multiply by 100%. So let's cross out the zeros here. This is 4, 1, 2, 3, 4. And then 1 0 here. All right. So cross out this. So what we have here is 25 times 10 all over 55. All right. So this is 250 all over 55. This gives us 4.55%. So we enter our answer, 4.55. So that's solution to question number 1A. Then the II here, say write in its simplest form the ratio of the areas of the rainforests, Valdivian ratio, Atlantic ratio, Congo. All right, so we are going to have Valdivian, which is 250,000 ratio. If you look at Atlantic, we'll go back to this table. You can see Atlantic here. That's 1,315,000. Ratio Congo. If you look at Congo, Congo is 2 million. So we want to bring this to the lowest term. We have 3 zeros here. So we are going to cross out 1, 2, 3. 1, 2, 3. 1, 2, 3. So this gives us 250 ratio 1,315 ratio 2,000. Okay. Now we can reduce this further. Okay, let's see this. Okay, we can use 5. We can use 5 to reduce this. So if we use 5 to reduce these numbers, all right, we're going to have 50 here. If we divide by 5, 1,315. If you divide by 5, you are going to have 263. And if you divide 2,000 by 5, you are going to have 400. So this is the least that you can get when these numbers are brought to their lowest form. So we have 50 ratio 263 ratio 400. Okay, let's proceed. Now we are told that the Amazon rainforest has 60% of its area in Brazil and 10% of its area in Colombia. 43 1/3% of the remaining area of the rainforest is in Peru. Find the percentage of the Amazon rainforest that is in Brazil, Colombia, and Peru. Okay, so what we are going to do here now is we are going to look at Brazil. How many percentage? In Brazil, 60% of its area is in Brazil. Okay, then in Colombia, we have how many percent? We have 10% in Colombia. Okay, so that gives us a total of 70%. Then they said 43 1/3% of the remaining area. Okay, so we are going to get remaining area. The percentage of the remaining area is going to be 100% minus 70%. And that gives us 30%. This is the remaining area. And here, 43 1/3% of this remaining area is in Peru. So let's get that of Peru. Give us 43 1/3% of 30. So now this, if you look at this and we clear this together, this is going to give us, if you turn 43 1/3 to an improper fraction, give us 130/3. All right. Okay. Then, because there is a percentage here, okay, this is, okay, let's return this percentage, then times 30%, all right? This is going to give us, agree with me that 3 can go here. That is 130, we have 130% times 10%, all right? And also remember that 130% is 130 all over 100, then times 10%, okay? All right, so that gives us, if you cross out all these zeros here, okay, that gives us 13%. So in Peru, we have 13%. And now the question is, asking us to find the percentage of the Amazon rainforest that is in these three places. So we are going to add the percentage in Brazil. Okay, we are going to take percentage in Brazil plus the percentage in Colombia plus the percentage of the rainforest in Peru. Okay. In Brazil, we have 60. Okay. In Colombia, we have 10. And in Peru, we have 13%. So altogether, this is going to give us 83%. So 83% is going to be the final answer, and we enter it here. We'll move on now to the next question. Here I said the area of the Amazon rainforest represents 27/50 of the total area of rainforest in the world. Okay. Calculate the total area of rainforest in the world. Give your answer correct to the nearest 100,000 square kilometers. So now this area of the Amazon rainforest, that is, we are told that the area of the Amazon rainforest represents 27/50 of the total area. So since we don't know the total area, this is, the Amazon rainforest, if you go back, you remember from the charts, the Amazon rainforest is 5,500,000. So what we are saying is, in essence, is that if you do 5,500,000, okay, over the population of the rainforest in the world, and you bring it to the lowest term, it's going to give you the left-hand side. So we take this relationship and we work towards making P the subject of the formula here. All right. So when you cross multiply, you get 27P equals 5,500,000. Okay, then times 50. So P represents the total rainforest of the world, total rainforest, in the world. So we have 5,500,000 times, I think that should be one more zero, times 50 all over 27. Okay. Now, if we multiply this out, this is going to give us P equals 10,185,185.185, right? And some other floating part of this decimal. So to the nearest 100, of course, if you look at it, to the nearest 100, we still have our 10,185,000 is close enough to 200,000. Of course, to the nearest 100, if you look at this, you are going to, approximate upward. So this 185 becomes 200 because it's closer to 200 than to 100. So to the nearest 100,000, we are going to have 200,000. So this is what we get. Okay. And that will represent the total area of rainforest in the world to the nearest 100,000 square kilometers. So enter the answer here. All right. Now, the next question said, in the world, 60.7 hectares of rainforest are lost every minute. Calculate the total area in hectares of rainforest that is lost in 365 days. Give your answer in standard form. So here, we say in 1 minute, okay, in the word loss, this, okay, this is what is lost in 1 minute. In 1 hour, okay, that means in 60 minutes, which is 1 hour. So this is what will be lost, okay? Okay, so in 1 hour, we have an equivalent of this, which if we multiply out, it gives us 3,642 liters. This is what is lost. Now, in 24 hours, which is 1 day, in 24 hours, this is what is going to be lost times 24, okay? And this gives us 87,408 hectares, okay? In 24, so in 1 day, we have this amount of acres lost. So therefore, in 365 days, this will give us, we are going to multiply by 365, that's 87,408 times 365 acres, okay? Now, this we can write this out. It gives us 31,903,920. Okay, that's okay. So this is going to give us in standard form. We are going to move how many steps? We are going to move this way to return it to standard form. We are going to move from the back. 1, 2, 3, 4, 5, 6, 7. So we're going to move 7 steps back. So this becomes 3.190392 blah blah blah, okay, times 10 raised to power 7, which we can, to 3 significant figure, become 3.19 times 10 raised to power 7. So this is what we have. So our final answer. Okay, so we proceed. Question 1B says, the Amazon River has a length of 6,440 kilometers, correct to the nearest 10 kilometer. The Congo River has a length of 4,400 kilometers, correct to the nearest 100 kilometer. Calculate the upper bound of the difference between the lengths of the Amazon River and the Congo River. So what we do here, first we take the length of the Amazon River, which is 6,440 kilometers. We are going to break it into upper bound and lower bound. Now, since the length is rounded up to the nearest 10 kilometer, we are going to divide this 10 kilometer by 2. And that is going to give us 5 kilometers. So we are dividing by 2 because we are going to share this between the upper band and the lower band. So we are going to use +5 for the upper band and -5 for the lower band. So when we add 5 to 6,440, it gives us 6,445. This will be the upper band of that length. When we subtract 5 from 6,440, it gives us 6,335. This will be the lower band of the length. Now we want to, here, that is for, this is Amazon. So now we are going to do for Congo. For Congo, we have, the Congo River has a length of 4,400 kilometers. We're going to break it into upper band and lower band, okay? So the upper band, this is correct to the nearest 100. So we are going to have plus or minus 100 over 2. So here we are going to have plus or minus 50 for the limit. So for the upper band of the length of this Congo River, we are going to add 50 to 4,400, and that gives us 4,450 kilometers. And for the lower band of the length of Congo River, we are going to subtract 50 from 4,400, and that gives us 4,350 kilometers. All right. Now, we are looking for the difference between the lengths. Naturally, the difference without looking at the bounds supposed to be 4,440 for the Amazon River minus 4,400, which is the length of the Congo River. So, but now since we are looking for the upper bound of the difference, that is, we want to obtain the maximum value, the greatest possible value from this difference. That means we'll be subtracting the least value from the greatest value. So we'll be subtracting the least value of the Congo length from the greatest value of the Amazon River length. The greatest value of the Amazon River length is 6,445, and the least value, which is the lower bound of the Congo River length, is 4,350, all in kilometers. So when we look at the difference between these numbers, that is 2,095 kilometers, and that will be our value. We proceed to the next question, that is question number 2. Question number 2, let's reduce this. Okay, so this is what we have here. Now let's look at the question. The question says, on the grid, draw the image of triangle T after a reflection in the S-axis. Okay, so this is the S-axis. This is the S-axis. Now, we take, this is our diagram T. So we look at the difference. When we take, we can call this triangle, you can just call this A, B, C, okay? So we start from vertex A. If you look at the distance from vertex A to the axis of reflection to this S-axis is just one vertical line above. So the image is going to be a vertical line, vertical line away from this mirror line, away from the S-axis. So we are going to have the image here. Then let's go to B. If we go up, B is 1, 2, 3 steps to the S-axis. So we are going to take 3 steps away from the S-axis. So we are going to take 1, 2, 3. Okay, we are going to have B prime here, which is the image of B. Now look at C here. C is 1. Look at where C is now. So C is 1 step, 2, and 3. 3 steps away, below the S-axis. So the image is going to be 3 steps above the x-axis. So we take 1, 2, 3. So this is the image. So now what we are going to do here is to join A to B. Then we join A to C, and we join B to C. So this is T prime, which is the image of triangle T. Okay, having done that, we are done with this part. Then the next part said, on the grid, draw the image of triangle T after a translation by the vector -5, -2. Now, the general vector for every translation is x, y, right? So these are movements. The first component is movement along the x-axis. When it is negative, we are moving back. When it is positive, we are moving forward, taking steps, right? And then the y component is also movement along the axis of y. So what we are going to do now, we take the point A, we take 5 steps back, that to give us that translation of -5. So, and then we are going to take 2 steps down. So we take 1, 2, 3, 4, 5. 1, 2, all right? So we have A, okay, let's say prime prime. So that will be the image of A after translation by the vector -5, -2. Let's take B. We'll take 5 steps back, 2 steps down. So we take 1, 2, 3, 4, 5. 1, 2. All right. So this is B prime prime, which is the image of B. Okay. After the translation. And then we take the next one, which is C. We take 5 steps back, which is 1, 2, 3, 4, 5. 1, 2. So this is C prime prime. So what we do now is to join this together. All right. Let's do that. Okay, which color? Okay. So let's join. This is A. Okay, so remember this is point A. If we look at A is 1, 2, 3, 4, 5, 1, 2. So this is point A here. This is point B here. So this is the A prime prime, B prime prime. So we join together. Okay. Then B prime prime to C prime prime, we join together. And we have this, okay? This is translation of triangle T by the vector -5, -2. Then the next is enlargement. On the grid, draw the image of triangle T after an enlargement by scale factor -1/2 with center -1, 1. So let's go and find the center. Now, -1 is, this is 0, this is -1 here, and then this is 1. So this is our center here. Let's call this our center to be our O. Okay, the center has moved. Okay, beautiful. Now, remember that the scale factor is -half, meaning that this object here, this triangle T, the image is going to be half of this entire triangle T. Of course, the negative here tells us that the image is going to form at the opposite side of the center. That means the center of this transformation is going to be between the object and the image. All right. So we are going to see how that can be done. So what we do here now is we are going to make a move. Let's look at triangle T. and we are going to enlarge, point by point. Let's take point A. Remember that our scale factor is -1 all over 2. So we are going to take a step now. A will travel 1, 2, 3, okay? Travel 3 to the horizontal, 1, 2 before it gets to where the center, the new center is. So this is the vector for, this is the vector for A, all right? This is the vector. It takes -3 because it's going back, and then 2, okay? Now, this is the scale factor. The scale factor is half, okay? This negative, I've explained what this negative is. This negative is just trying to tell us where the image is formed with reference to the center. So the image is found immediately after the center, okay? Now, what we are going to do, we are going to divide this movement along the S by 2. So instead of having -3, we divide by 2, you are going to have, this is the step we are going to take, okay? From the center now, we are going to take 1.5 steps towards the negative S axis, and then we are going to take 2 over 2, all right? Divide 2 by 2 or multiply 2 by half. So we are going to take 1 step forward, okay? The vector we are going to use now to get A prime 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 is this vector here. We are going to use this vector here, -1.5 and 1. How did we get -1.5? Divide this by 2, divide this by 2, or multiply this by half. That is the scale factor, or multiply this by half. Like I said, for the scale factor, we ignore the negative. The negative is just telling us the position of the image. So from the center, to locate A prime prime from the center, we are going to take 1.5 step behind. So we are going to take 1.5. So this is where it is, 1.5, and we take 1 step up. So this is where A prime prime, okay, will be. So this is it. Now, let us take B, okay? Now, we are going to get a vector for B. Let's clean up this. The same way we did for A, we are going to do for B, okay? Now, if you look at B, B is 1, 2, okay? Okay, the vector that moves B is -2, because we are going behind. 1, 2, then we go up 1, 2, 3, 4. We have 4 here. Okay, for us to locate this image, we are going to use this movement. Multiply this -2 by half, it gives us -1. So we have this, and multiply 4 by half, it gives us 2. So we have these 2 here. So from the center, we are going to take 1 step to the back. That brings us here, and 2 steps up. 1, 2. Okay, it lands us here. This is going to give us B prime prime prime, okay? Okay, so we have this point, and we have this point. So for C, now let's look at the vector that is going to move C. C is 1, 2, 3, 4, 5, 6. So C is -6, And then we have 1, 2, 3, 4. We have 4, okay? So multiply minus 6 by half. That gives us minus 3. Multiply 4 by half. That gives us 2. So for us to locate C prime prime prime, we are going to take this vector minus 3 and 2, right? So from this center, we take 3 steps back. That's 1, 2, 3. Then 1, 2. Okay, so this is where C is. So we have C prime prime prime, okay? So now we are going to join this together. Join this. Beautiful. So that gives us the required image, okay? So hope you understand this. So we are proceeding to the B part of question number 2. Question 2B said a shape P is enlarged by scale factor 3 to give shape Q. Shape Q is then enlarged by scale factor 2/5 to give shape R. The area of shape P is 10 square centimeter. Calculate the area of shape R. Now, what we do here is you look at this. That means P ratio Q is 1:3. Okay. Since let's take the area factor. This is scale factor. So the area factor is 1/3 squared. And now we know here that the area of shape P is 10, but we do not know the area of shape Q. Okay, we have this. So I have 1/9 here equals 10 all over Q, right? So we can go on to cross multiply. We get area of Q is, so here, area of shape Q is 90 square centimeters, right? Then we also notice here that Q ratio R is going to be 2, is going to be 5:2. Because if you look at it here, shape Q is then enlarged by a scale factor. So this scale factor means that the object, the image is going to be smaller. That means shape Q is going to be bigger because this fraction is less than 1. It means the enlargement is going to bring about a smaller image. So that is why we assign 5 to Q and assign 2 to R, because the image is going to be smaller. The image is R, is going to be smaller. So we have that because the scale fraction is a fraction that is less than 1. Now we go on here to say, if you take the scale factor here, you will see that if you do Q over R, it's going to give us 5/2. Now, the area of Q is known to be 90, but we do not know the area of R. So this is area factor, the right-hand side. For it to become an area factor, we have to square the results. So you have 90 over R equals 25/4, right? So if you make 90, if you make R the subject, it's going to give you 90 times 4 all over 25, okay? And this is going to give us 14.4. So that means the area of shape R is 14.4 square centimeters. I hope we understand this. So we are going to have a short break and we will be right back in a very short time. Welcome back. This is Math Minders Academy. If you are new with us, we urge you to subscribe to our channel, click on the notification bell so that each time we produce a new video, you'll be among the first to release it. Share this video, like it, go to the comment section and tell us how you feel about this video so that we'll be able to enhance our production to serve you better. We are proceeding to question number 3 now. All right, so here we have this formula C equals 1 over 4sy squared. So we want to find C when S is 5 and Y is 8. So we substitute. That will give us 1 all over 4 times 5 times 8 squared, okay? So which is 5 times 64 all over 4. That's 5 times, this will go 16 times here. Okay, so this gives us 80 entirety here. Okay, find the positive value of Y when C is 15 and S is 2.4. So we have 15 equals 1 over 4 into 2.4 Y squared, all right? So we have 15 times 4 equals 2.4 Y squared, right? It becomes 60 equals 2.4 Y squared. So Y squared is 60 divided by 2.4. So here we are going to have Y squared to be equal to, if you divide 60 by 2.4, it's going to give us 25. Okay, so Y is going to be square root of 25. Of course, this is supposed to be plus or minus 5, but we are taking the positive value. The positive value, take notes. Positive value. So here we are going to take Y equals 5. We move on to question 3b. Write as a single fraction in its simplest form. So here you can cross multiply. We have 4 into 2x plus 5 minus 3 into x minus 1 all over. We take the product of the denominators. So we expand the bracket from the numerator. That gives us 8x plus 20, that's 4 times 5, minus 3 times s is 3x, minus 3 times minus 1 is plus 3. All over. Of course, you may choose to open this bracket, or okay, we can leave it, which is x minus 1, 2x plus 5, okay? And that is going to give us 8x. Of course, if we check 8s minus 3s, that gives us 5x. 20 plus 3, that gives us 23. All over x minus 1, 2x plus 5, okay? And that takes care of this problem, okay? Of course, if we expand and clear off the denominator, it's also acceptable. All right, question 3c, we are to expand. So we return this first bracket, 2x plus 3. Then we spread out 4 minus s, 4 minus s, okay, to make it a bit easy to understand. So we still hold on to 2s plus 3 and multiply 4 times 4 is 16, okay. Now this is the multiplication here. All right, I'm going to use this 4 to multiply this, okay. Then I'm going to use this 4 to multiply this. So that gives me minus 4x, okay? I'm going to use minus x to multiply this. That will give me minus 4s. I'm going to use minus s to multiply this. That's going to give me plus x squared, right? So let's still return this. We have 2x plus 3. We have this 16 minus 8x plus x squared, okay? Good. Now, we are going to multiply out again. So here, I'm going to use this 2x to multiply 16, and that will give me 32x. I'm going to use this 2x to multiply minus 8x. That is going to give me minus 16x squared. I'm also going to use it again to multiply s squared, and that is going to give us plus 2s cubed. I'm going to use 3 to multiply 16. That will give us 48. Use 3 to multiply minus 8. Minus 8s. That will give us minus 24x. Use 3 again to multiply s squared. That will give us plus 3x squared, okay? So now, let's see all the items that we are going to add together. Now, if you look at this, this is minus s squared. This is another one with power 2 here, okay? But this 2s cubed doesn't have any item to add up to it, so we bring it 2s cubed. So this minus 16 plus 3 will give us minus 13. So we have minus 13x squared. Now let's look at the s that we have here, and we are going to group them together. We have 32x. We have minus 24x. So you have 32 minus 24. So this is going to give us plus 8x, okay? So here we have plus 8x. Now look at the constants. We have 48, all right? Is there any other constant here? No other constant. So we have plus 48, okay? So this will be the last stage of this simplification. All right. So we are done with question number 3C. If you like our tutorial, please subscribe to our channel if you have not done so. Click the notification bell so that each time we produce a new video, you'll be among the first to get it. Share this video so that other students that need it, the YouTube algorithm will be able to send it to them. Let's proceed to question number 3D. We want to simplify these indices. So what we do here, first, to remove this negative, let's increase this. To remove this negative, we can take the inverse of this power, of this inner bracket. Of course, we can take the reciprocal of this. So if we do 16 x raised to power 16 all over y raised to power 8, so this can come as 3 over 4, okay? So now we can do something. Write 16. If you look at 16, 16 is actually 2 raised to power 4. And y raised to power 8 is also y raised to power 2 all raised to power 4, okay? So we can get this as 2 raised to power 4, if this is 2x, okay, then we are going to have all over y squared all raised to power 4. Of course, remember that 2 raised to power 4 is equal to 16, and then there is also s raised to power 4 here, okay? If you do this, let me explain that very well. If you have 2x all raised to power 4 is going to be 2 raised to power 4 multiplied by s raised to power 4, and that is going to give us 16s raised to power 4, okay? Raised to power, this is s, okay, so we are going to have s raised to power 4 here, okay? Very correct now. Okay, so this is correct. So now everything here will be raised to power 3 over 4, okay? Now, this 4 here multiplies 3 over 4. This we cancel out. So this gives us 2s raised to power 4 all over y squared, all raised to power 3. Okay? And if we multiply this out, 2 raised to power 3 is 8. S raised to power 4 raised to power 3 is s raised to power 12. Of course, this is going to be times 3 here. Okay, this is y raised to power 2 times 3. Okay, so this is going to be 8x raised to power 12 all over y raised to power 6. Okay, and that is for question number 3D. We'll move on now to question number 4. Question number 4. Gianni records the time in seconds that some cars take to travel 195 meters. The bus and whisker plot shows this information. So we are asked to find the median time. So the median time for this bus and whisker will be this line here. The median is going to be this line here. All right. Remember, in bus and whiskers, this is our lower band. Okay. This very one. This is the minimum number. Okay, that's the minimum. Okay, this is the maximum. This line here is the median. This is our first quartile. This is our first quartile. This is actually the second quartile, which is the same thing as the median. This is the third quartile. Okay, and this is the maximum. Okay, so the median is the second quartile here, and it corresponds to, this is 9.3. So we have 9.3 here for the median. All right. So we move on. We want to find the interquartile range. Interquartile range is actually the upper quartile minus the lower quartile. Okay. So that's Q3 minus Q1. So let's go and look at what Q3 is. If you look at Q3 here, this is 11. This is 11. This is 11.2, 11.4, 11.6. So we have 11.6 minus Q1. If you look at it, this is 8 here. This is 8.2. So we have 8.2. And look at that, it gives us 3.4. All right. So we'll write 3.4 and proceed. Now, the next question asks us to find the difference between the average speed of the fastest car and the average speed of the slowest car, and give our answer in kilometer per hour. Now, you understand that speed is total distance covered over total time taken. And so take note that the fastest car, we go with the slowest time. Okay, fastest car, we go with the slowest time, and the slowest car, we go with the fastest time. Okay, that means the greater the time taking, the slower the car. Of course, for the car to take more time, it means that the car has a slower speed. And the one that goes very fast, we save more time. So it will have the least time. So the one with the smallest possible time will be the fastest car. So let's get the speed of the fastest car. Speed of fastest car is the distance covered. Now, the distance is 195 meters, okay? The distance is 195 meters. So we'll go and put it, 195. Okay. And then, because we are looking for the speed of the fastest car, so the time here will be the slowest. Will be the least time. So let's go and check. Okay, so here the maximum time is going to be, okay, this is the maximum time, the greatest time. This is the minimum time in seconds. Okay, so the fastest car will be using this minimum time, which is 6 seconds. Okay, this is 6 seconds. Okay, now this speed of slowest car is going to be 195 over, this one we use the maximum time, which is 13. Okay, now we are going to find the difference. Here asks us to, it says find the difference between this average speed. Now you will see that the fraction that has the lowest denominator, the smallest denominator will be the bigger fraction. So we are going to do 195 over 6 minus 195 all over 13. Okay. So we will see what this will give to us. Okay, this gives us, all right, if we take the LCM here, which is 78, we are going to have 2,535. If we divide 78 by 6, it gives us 13 times 195. It gives us 2,535. If we divide 78 by 13, it gives us 6. 6 times 195 will give us 1,170. Okay, when we do the subtraction here, it gives us 1,365 over 78. Okay, now this is in meter per second. Okay, now if we want to convert, the numerator is meter. If you are converting that numerator in meter to kilometer, you divide by 1,000. So it gives us 1.365 kilometer. Now the 78 seconds here, if you convert it to hour, if you are converting seconds to hour, you are going to divide by 3,600. Okay. This is 78 over 3,600. I will explain it here. Remember that 60 seconds, if you look at it, 60 seconds is 1 minute, okay? And 60 minutes is 1 hour. Now, this 60 minutes is 60 times 60 seconds, okay? Which is 3,600 seconds for 1 hour. All right. So this becomes 1.365, okay, times 3,600 all over 78, okay? And this will give us 600, this will give us 63 kilometer per hour. This is kilometer per hour, okay? So this will be the final answer. So we've been able to find the difference between the average speed of the fastest car and the average speed of the slowest car in kilometer per hour. So we write this here. And we proceed to the B part of that question. Question 4B says, Matilda records the distances that 80 different cars can travel with a full tank of fuel. The table shows this information. Write down the class interval that contains the median. If you look at this, the median, all right, remember they are 80. So the median be around the half of 80, which is the 40th item. Okay, the median will be around the 40th item, right? So if you count here, this is 7 plus 13, that's 20. 20 plus 19, that is 39. So the median steps into this class. This is 39, and you know, this is the 40th item. So the 40th item is, you know, is part of this class here. So the lower bound of this is 420, and then you have the upper bound as 450. All right, so that's the median class. Now we want to estimate the mean. Okay, for us to get the mean here, all right, so we said this is the median class. So for us to get the mean, we are going to take the midpoint of each of these class. How do you get the midpoint? For this first class now, the lower limit is 250, the upper limit is 300. If you divide it by 2, you get your midpoint. So this will give you, it's going to give us 550 all over 2, and that will give us 225. That will give us a 275. 275, okay? So this is 275. Now here, if we add 300 and 400, we get 700, and we divide by 2, that gives us 350. So this is 350. Here, 400 plus 420, that gives us 820. Now, if you divide 820 by 2, that gives us 410. So we have 820 over 2, and that gives us 410. So this is 410. All right, this is 410. Here, add 420 and 450. That is going to give us 870. If you divide by 2, 870 over 2, that will give us 435. 435. Here, add 450, 500, that's 950. If we divide 950 by 2. That will give us 475. Okay. So with this information, we want to find the estimate of the mean. So we have 7 multiplied by this midpoint plus the frequency of the second class is 13. Use it to multiply the mid value of that second class. Frequency of the third class is 19. We use it to multiply the mid value of that class. We continue like that. 21 is the frequency multiplied by the mid value plus 20 is frequency multiplied by the mid value. All over 80 because there are 80 cars. So if we multiply all these quantities with our calculator and add them together, the numerator will add up to 32,900. I am very sure you can use your calculator to multiply out and add. Then all over 80. And this will give us 411.25. Okay, so yeah, right, 411.25. Question 4B, III. We are told here that a histogram is drawn to show the information in the table. The height of the bar for the interval 250 less than D less than equal to 300 is 2.8. Calculate the height of the bar for each of the following intervals. Now, if we look at this bar here, if we go back to the table, this bar 250 to 300 has 7 as its frequency. And we know that when a histogram is drawn, the height of the histogram bar is the same as the frequency density. So the height of the bar is determined by the frequency density. So now, the frequency density itself is defined as frequency over class width. So we say frequency density is frequency of the class over the width of the class. Now, for this very class here, the frequency is 7. The width is 300 minus 250, and that gives us 50. So the frequency density of this class is 7 all over 50. And if you look at 7 over 50, it is 0.14. But here, 0.14 has been scaled to 2.8. That means 0.14 multiplied by a particular value is going to give us 2.8. Now, if we look at the multiplier, it's 2.8 all over 0.14, and that gives us 20. All right? So that means for every frequency density that we calculate, we are going to multiply by 20, because that is the factor that is used to scale up to 2.8, to scale 0.14 up to 2.8. So we look at the question now. We go to this class here, 300 to 400, and we are going to look at the frequency. From the table, 300 to 400, the frequency is 13. So we go back, the frequency is 13 for this class. So if the frequency is 13, the frequency density is going to be 13 all over the class width is 400 minus 300. So 400 minus 300 will give us 100. That is the class width. And it gives us 0.13. So this 0.13 now, we are going to scale it up using 20. So we say therefore 0.13 times this our multiplier will give us 2.6. So this is 2.6. We look at the second class. This class here, 400 to 420. Go to the table to check the frequency of that class. 400 to 420, the frequency is 19. Come back here. So it means here that the frequency density of this class is going to be 19 over the class width is 420 minus 400. That is 19 all over 20. We have 19 all over 20. So we are going to multiply by the factor 20, and that gives us 19. So here we have 19. So we go to this particular class, we go back to the table and check this class that has 420 to 450. We check the class that covers 420 to 450. The frequency is 21. Okay. We return back, the frequency is 21. So here, the frequency density of this class is going to be 21 all over. The limit is the difference between 450 and 420, which is 30. Okay, so if we now multiply 21 over 30 by 20, that gives us 14. Okay, that gives us 14. So here we have 14. Now we take the last question to number 4, that is 4B IV. Here it says 2 of the 80 cars are choosing at random. Find the probability that with a full tank of fuel, one of the cars can travel more than 450 kilometers, and the other car can travel not less than 300. Okay, so we are looking at not less than 300. That is, okay, not more than 300. Here, the car can travel not more than 300. That means we are looking at 300 or less. And, okay, one of the cars can travel more than 450 kilometers, and the other can travel not more than 300. Okay, so we have this. We now go back to look at this very scenario. We want to look at the car that can travel more than 450 kilometers. More. The one that can travel more than 450 is this last class here, 20. Of course, this is D greater than 450. So more than 450, we have 20. We have 20 here out of 80. There are 20 there. And the second one must not travel more than 300. If it's not going to travel more than 300, not more than 300 is where we have 7. This is not more than 300. That's the first class. Not more than 300. That's the first class. So we have 7. But if we have chosen if we are choosing one car out of 80 cars, the second choice, the second selection will be made from 79 cars. So this is 79 because usually this is without replacement, because we are not told that the cars were returned back. Now, this can also be choosing, in two different ways. It's either the first is taken, which is 20/80 before the second, or the second, is picked at the first, and then the first is picked at the second. So there are two ways this can be done. So if we multiply this by 2, we'll get 280 all over 6,320. And this, if you divide by 40, is going to give us 7 all over 158. And so we enter our answer here, 7 over 158. This is where we will end the first volume of this tutorial class. If you find this video interesting, we urge you to go ahead and subscribe. If you have not subscribed to our channel, hit on the notification bell so that each time we publish a new video, you'll be among the first to receive it. Share this video, like it, go to the comment section and tell us what you feel about our video. Let us know how we can improve our videos to serve you better. This is Math Minders Academy. We'll be looking forward to see you in part 2 of this tutorial class, where we'll be taking solution to question number 5 down to question number 9. We see you in our next class. Thank you for being with us.
In the midnight glow where the stars align, we lose ourselves in the rhythm divine. Underneath the sky painted with dreams, we're chasing the echoes of silent screams. Caught in the spell of the cosmic night, where fantasy